Hey geometry class, this is going to be our last video in this chapter. It's going to be about section 5.6, inequalities in two triangles. If you understood the last section on inequalities in just one triangle, then this one isn't going to be so bad for you at all. So our objective is to apply inequalities in two triangles. Here are our theorems about inequalities in two triangles. One of them is called the hinge theorem. And here's how it goes. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, the longer third side is across from the largest included angle. Okay, so let's look at these two triangles right here, triangle ABC and DEF. And what this is saying is if we have, okay, AB and DE are congruent and AC and DF are congruent, so two pairs of sides of both triangles are congruent to each other. This included angle, angle A, and D, if angle A is greater than angle D, then that third side that has the larger angle that's opposite of that third side must be the larger side when comparing these two triangles together. So BC in this triangle is going to be greater than EF. Okay, and then we also have the converse of the hinge theorem that pretty much states the same thing, but instead of given that the angles are one angle is larger than the other, we are given the third side here is larger than the other third side. So whenever we are given that, say, GH is greater than KL, then we should know that the one that has the greater side length has the larger angle. So angle J is greater than angle M. So let's do a few exercises on these hinge theorems and its converse. First, we're going to compare the measure of angle BAC and the measure of DAC to each other. So the hinge theorem goes like this. We have two triangles here. This segment and this segment are congruent, and we know AC is congruent to itself. And we see that BC is larger than DC. So the angles opposite of these two sides right here are what we're comparing, the measure of BAC and DAC. And how we're going to compare those is just with an inequality symbol, whether it's either greater than or equal to or less than. So let's write it out. Measure of angle BAC, and let's skip a little bit, a space here. We can say that the measure of BAC, which is this right here, the one that's opposite of the larger side, must be greater than the one that is opposite of the smaller side. Okay, so that's how we're going to compare things when we're asked to compare things with a little inequality symbol in between them. Okay, let's move on. All right, right here. Again, we're asked to compare a couple of angles in this figure here. And let's see, we have this side and this side are congruent, and these are common sides. So angle EGH, this one right here, is opposite of the side that is smaller than what EGF is opposite of. So how we're going to say this is the measure of EGH and the measure of angle EGF. EGH has the smaller side, so it is less than the measure of EGF. Okay, now we're going to be using the converse of the hinge theorem and comparing sides of our triangles that we are comparing. Okay, so let's look at it this way. Let's find first the measure of this angle over here. So EG, that's a straight angle. So these two angles, 82 and what we're trying to find, are supplementary. This is going to be 98 degrees. There, 98 degrees. Now, this segment and this segment are congruent, and they share a common side, so we know they're congruent. Now, EF is opposite of that angle. FG is opposite of that angle. And EF has the smaller angle of the two opposite sides, so we're going to say EF is less than FG. Just like the last example, let's look at this one. We have, again, using the hinge theorem, this side and this side are congruent. We are sharing a common side again. And 46 degrees, that angle is opposite of side AB. And 65, sorry, I said 46, I meant 64. As 65 is opposite of this side, BC. So BC is opposite of the larger angle, so it is the longest side. BC is greater than AB. Okay, hopefully y'all are understanding how I'm coming up with these answers to these exercises here. If not, please, I will explain it further to you in class. Okay, in this one, we are, like in the last section, we're asked to find the range of values for something using inequalities. We're going to do the same thing in this one. It says find the range of values for K. So here's K in this one. And how we're going to figure out the range is using that hinge theorem. See how PN has the smaller side. These two sides are congruent. This side is congruent to itself. So this angle that's opposite of this side and this angle that is opposite of this side, we can apply the hinge theorem to. Since 18 is less than 19, this angle right here is less than 38 degrees. So that's how we're going to write it out. We're going to say 5K minus 12 is less than 38. And then we're going to solve that inequality for K. Okay. So add the 12 to both sides. We get 5K is less than 50. Divide both sides by 5. We get K is less than 10. So that is going to be our range for K. K must be less than 10. Okay. All right, let's do the same thing on this one to find the range for z. And again, applying that hinge theorem, this angle is larger than this 90-degree angle. Okay, so we can say that z plus 23 is greater than z, or 3z plus 9. So z plus 23 is greater than 3z plus 9. All right, so solve this inequality now. Subtract the z from both sides. We'll get 2z on this side. Subtract 9 from both sides of the inequality, and we get 14 on this side of the inequality. Now divide both sides by 2. We get 7 is greater than z. Or we can flip this inequality around and say z is less than 7. And that is our solution. Z must be less than 7. Okay, so let's look at the next problem here. The next problems I have for you are actually part of your lesson quiz, so you do this on your own and we will discuss it in class when I see you next. So this is it. Goodbye, everybody.